too far.
Yeah, you can see I have completed exactly 3. I have started many others, but I have completed
Yeah,
3.
after like the whole remaking a file system, I was like, you know what? Maybe I should just put this down because I should actually be writing a bunch of blog posts for
Right.
Unison instead.
Yeah. So what do you say? Should we just like do the like the latest one and work on it?
Yeah,
I have not even looked at it yet, kind of
yeah.
intentionally. All right.
I looked at it. I started on it, but I did not get very far.
Okay. Let's have a look then. Unless something else we want to talk about or do first or look at or anything.
I think that sounds like a great plan.
All right. So let's see what we're
Stu,
doing.
are you sharing your screen?
I thought I was. Do you not see it?
Mm, I do not.
Okay. I I will share my screen. Let's see. Screen share. I want screen 1. Do you see my screen now?
Yes, I do.
You see my browser and my VS Code, right?
Yeah.
Perfect. All right. So here we are, Regolith Reservoir. The distress signal leads you to a giant waterfall, actually. Signal is coming from the waterfall itself. There's a little path that leads behind the waterfall. There seems to be a large cave system here. The signal definitely leads further inside. Okay, sand begins pouring into the cave. You could become trapped for... Okay, where are we going with this? Fortunately, your familiarity with analyzing the depth of falling material will come in handy. That's good. Okay, you scan a two-dimensional vertical slice of the cave above you. Two-dimensional vertical slice. And you discover that it is mostly air with structures made of rock. Your traces of path of each solid rock structure reports the XY coordinates form the shape of the path, where X is right, Y is down. Each path appears as a single line of text. Okay, that's good. Each point indicates the end of a straight horizontal or vertical line to be drawn from the previous point. All right. This means that there are 2 paths of rock. The first consists of 2 straight lines, and the second of 3 straight lines. Okay. Oh boy, that sounds complicated. Okay, so it's pouring in from 500 comma 0. Okay, 500 0 plus is where we start. Wow, sand is being produced 1 unit at a time, and the next unit of sand is not produced until the previous unit of sand comes to rest. The unit of sand is large enough to fill 1 tile of air in your screen. That's very large sand. Falls down 1 step if possible. If the tile immediately below is blocked, tries diagonal. So drawing sand that has come to rest as O, the first unit of sand simply falls down and stops. Okay. Wow. All right. How many? So,
Okay.
wow, this is something else. Using your scan, simulate the falling sand. How many units of sand come to rest before the sand starts falling into the abyss below? Wait. Okay. So the abyss is if they fall off the bottom of the world. Is that right?
Yeah.
right. Wow. All right. So our input's going to look like this. All right. So in this case, it is 484. Oh, sorry, 498, comma 4 to 498, comma 6. And 4. Wow. 496, comma 6. All right. Wow. Okay. That's a lot.
Okay.
This is a lot. These are harder than I expected. In the beginning, it was
this
like
one is like
it was like some
building
counting things in the beginning.
cellular automata.
Yeah. All right. So what do we, well, let's start with something easy. Can these things go off? Is there a bounds? I mean, are they bounded?
I think you.
Can I assume they don't go to 0? We're going to start that way. We're going to start that way.
I modeled mine with gnats, and I implemented as far as the parser, so and it parsed okay.
All right. So we need to parse these things.
I've done today's, and I got away with gnats.
Perfect.
Cool.
Perfect. All right. So let's see. We need to parse. Are they going to literally have these arrows in them, we think? This is what a thing looks like?
I think they do, yes.
All right, this is test input then. Let's... All right. Oops. All right. So we need a quick parser. I'm gonna use, so let's say, let's start calling these things. What are we on, day 14? All right, so we are gonna need day 14 dot parser is going to do pattern, is gonna be a text pattern guy. Which I always kind of have to look up, so I'm just going to look it up right away. Okay. Yeah, so we're going to get... okay, so our pattern is going to be... It's going to be pattern.join a bunch of things, which we are going to... Actually, it's going to be the sep. It's going to be the sep thing. Sep sum. I can never remember which order these go in, but I think it's the separator and rep. But the separator is going to be literal. One of those with some optional white space. Is that right? So.
Make it simple, you could just surround your literal text with 2 white spaces.
You think it's... Oh, you think they're always going to be there?
Yeah, I think that they
yeah, I guess I can assume.
might be nice too with the input and like not
yeah
weird characters.
Okay, so that's separate those by a and this is going to be a patterns dot sum. I think it's going to be something like that. Let's give it a shot. So we're going to do pattern dot run our day 14.parser. Copilot knows where we're going with this. Okay, say what? 6, line 6. It doesn't know what we're doing already. We don't have anything there yet. No, day 12. Sorry, line 12 it was. Quote, quote, quote. Everything looks good to me. Let me see. Line 5.
So your unique type, did you want unique type point equals point?
Definitely. That's pattern.
Singular pattern.
Yep.
Oh, is it non-completing? Oh no.
It is. We got just the 498. I forgot the commas. Right, we got to do. Let's get a. I'm gonna just do another. Oops. Okay, this one's gonna part. We're gonna use that here. And this one is going to be. No, it's not really that. It's really going to be 3 of these things. It's going to be a number, a comma, a number. And a number is going to do a thing. We might, well, we're just. We're going to. Pattern.digit, I thought was a thing.
Yeah, I thought so too. Patterns.digit. It's plural. Yeah, that's a bit confusing.
It's a lowercase one. All right. Now what do we have? We have a. All right, we got the first line. So each one of these is what? What are these called? Is this like a wall, a shape? What is this? It's a trace, is what they called it. So let's actually call this a. This is actually parsing a. And then what the. This is going to be pattern.sepsum. No. All right, now we have a whole list of things, and that's not good, because now we can't tell which is which.
Oh.
This is something. All right. What we're going to do is. We're going to. This is. What is this actually going to produce? This is actually going to produce a list of a net. Is what we hope it's going to produce, right? Our list of point.
Point.
Let's just do the thing. And what is this doing? This is going to take text. Let's just split it. How about that?
Yeah. Hey, Simon.
And then for each one, we're going to run what is that going to give us? That's going to give us a thing that we're going to have to... So we really don't want to... Actually, can we not capture all of this? Yeah, why? Hang on, before we do that... Hang on, I want to move this capture around because I realized we didn't... I think we captured too much. Before we do that, let's put us back the way it was. It was pattern dot zep sum. Yeah, this, but we don't want to capture. No, we don't want that. We want none of that stuff. But here I don't want to capture. I want to just capture inside. What does this look like? This. Even worse. That's okay, that we're gonna use it. That's still good. All right. Okay, you come back to life. All right, so we're splitting that, and we're running that, and this is going to give us a list of gnats, I believe. So now this is really a parser that we just run on the input. We're just going to assume this runs. All right, so it's just, all right, okay, this is our, these are the lines we got, which just, I'm going to list.map a thing on these things, and our list.map is going to run cases. How are we going to do this? We're going to just assume it works. Some results and some junk we don't care about anymore if it works. I'm just going to return the results, which is really going to be text. All right, second argument to list.map is that on each line, I want to wait. On a list.map, I want to really do this. This is a line. We're going to run the parser on the line, and then we're going to.
Want a match on it?
Yep. Exactly. All right. Okay, for each one of these, what are we going to do? This is like a... let's see. We're going to call this trace pattern, and then let's make a 14.trace parser, which is going to take these lists of text and turn them into lists of point. And nope, poor guess. And what we're going to do is take these as we're in an empty list. How is this going to go? This is going to be go. No, yeah, we're going to do it like that. So when we're out of them, we return the. Otherwise, we're going to take 2 at a time and say it is going to be x comma y and the rest.
Oh, I think there's a list dot sliding pairs if you wanted it.
Well, no, I just did it. I don't know. All right. Okay, so what are we doing here? This is really. This guy is going to go into here. Well, into there. And then we're going to into, let's just, it's going to be list.map. So now we should have a list of points, except these we need to parse. These are not ints yet. These are not nats yet.
Mm. Oh, right. The pattern doesn't do any
Yep.
translations of the different types. It just parses things.
That ought to do it. Let's make this look a little bit more.
Does from text return optionals?
Yes,
Okay.
I think. Okay. Let's see. How are we doing? We forgot to call go with our empty thing and all the inputs. Oops.
That looks good.
All right. Now what the heck?
I feel like we should make a map.
Sounds good to me. We're done with this guy. And what does this have? This has like, yeah, this is gonna have to have. This is gonna be a.
To sell.
Okay, I'll do that. Okay, what does this look like? This is like gonna be either a. This is like either empty or wall or sand.
Sand.
Yep.
Do you want your day 14 map? I meant to just use the base map, but it looks like you're writing a wrapper type of some kind.
You're right. Let's not call this map. Let's call this grid or something. And this is going to be a grid like this. Yeah, let's.
Yeah.
All right. Can we do this? What does this take? This takes text, and it's going to give us a grid, and a starting grid.
Mm-hmm.
So what do we do first? We want a list of points. We want a list of points.
Yeah, I wonder if we should first
Yeah.
just operate on the point thing and do like a fill, like point dot fill, to create a list of points.
Yeah. So let's take a I don't know. We'll figure out. Yeah, for now, until I figure out what to call it, we are going to call it fill. What is this going to take? That's going to take a list of points. And what is that going to... And return... Actually, a list of points again.
Yeah.
All right. All right, Phil. What you got? Okay.
I think we need to take a list of points.
I want to deal with one. So one of them is going to describe like one of these shapes, right? One list of points describes one of these shapes, right? It's going to be like, is it? Wait, what? Again, hold on, let's see.
Oh yeah.
So I want to take like one list of these and turn it into the, like this one would be a list of 3 different points, but I want to turn it into a list of 5 different points that I just want to fill in the grid, right?
Yeah.
Yeah.
Okay, cool. All right. All right, so first we're going to need like some inner function that's going to be, all right, let's say this is going to be our inputs. But like we need something that says like given an x, we need something that given an x and a y, it's going to tell me like, I need to turn it into a list of points, right? Or I need like something that turns a point into a list of points? No, how does this work?
I
2
think
points, 2 points.
So for the list of points, it's gonna come in like 498, 4, 498, 6, and
Right.
the ordering there is really important. So I think we should do the sliding window thing again, where we've got like points A and B. Test whether the x or the y is the same, and if the y's are the same, then you're filling x's, and if the x's are the same, then you're filling y's. Oh wow, did it just write that?
Yeah, Copilot just wrote this.
I need to get on this Copilot thing. I'm doing everything like I'm in the Stone Age.
All right, let's see how Copilot just did. Day 14 dot. Yeah, sure. Copilot's ready to test. Where don't you like that? 34. Sure. This is a day dot point and a day 14 dot cell. Yeah, I never did anything with this yet. Okay, this is gonna be, okay, this is the sliding window thing. All right, I don't know about this thing. I'm gonna have to look it up. Is it called sliding window literally?
What is it called?
Sliding pairs.
Push.
Sliding pairs sounds great. Perfect. Okay, so we're going to take our inputs and we're going to run them through sliding pairs. And then we're going to run that into list.map with something. What are we calling something here? This is like...
raw line?
Yeah, I'm calling it line. Okay, so that gives us... And now we want to like flatten, right? Do we have a list.flatten? I always know I have this. All right. And so fill on... Right, this is tupled now.
Well, you can, if the function's too spicy, you can also uncurry it.
You are good. Yeah, I like that. I like that better. Fancy pants. Okay, sliding pairs on line, which we will unfunction.uncurry. Okay, we need some inclusivity somewhere, right? No, what happened? Why did this not work? Okay, so we have x equals x, yes. If y is less than y, yes. Range from y, this should be plus 1, right? No, lie. Hold on. So so it's smaller on the left. Then we want to go range from y prime to, wait, how does that work? We want the smaller one. No, yeah, y to y prime plus 1. Else we want the smaller one would be, oh yeah, way to go, Copilot. Y to y.
You could also use range closed if you didn't want the plus ones.
Like it, yes. This is this, okay. And here, I'm just going to delete this, and Copilot's going to know what to do. All right. I don't know that I believe that list.pointx is the right thing. How can that possibly be?
Yeah, I feel like one of these is not correct.
Yeah. Point x. That's good. That's fine when x is equal, and then otherwise when y is equal, this is going to be an x into point xy.
Yeah.
And okay, I definitely want to do more tests now. In fact, all right, I think this guy is going to graduate to a real name, too. Oops, no, not like that. Phil. All right, let's test Phil a bunch of times with test.random do ensure equals, we're hoping for 0.11, 0.12, 0.13 for this.
We really need to rename test.random. That was a test.
Yeah. We're gonna. I think Runar's gonna take that up soon. What's wrong here?
Do you need to do D14 test fill equals?
I do. Thank you. All right, passed. Let's make more. How's that look? That's the same. That's good. Sure. All right. All right, now this, we've only tried it with 2 inputs. Let's try it with 3. Oh, it's way ahead of us. No, it's not. No, let's get rid of that. Let's copy this one and give it a, what would be, so 3 to 1, and then
Like 1 to
1, 3. This is, we're gonna let it fail and see how it looks when it comes out. So we got 1, 1, 1, 2, 3, 1, 1, 1. Okay, this tells me this looks good, but we don't really want this. We really want a set, don't we? Or do we not care? We don't care that there's redundancies in there. We want a set, don't we? It's gonna be easier to test if it's a set. Okay, and this is gonna be that fold left on this is what ACC. This is whatever. Just set union. And then all of these guys become set dot from list. What do you think? How do we do? 38. I know my test is still wrong, but
your
these need to return sets now.
yeah.
Ensure equal. One side is list point, one is a K to set. That's all wrong. Yeah, I need to wrap all this stuff. All right, this should be just our failing test, and this one needs some more stuff like 0.12 and 0.13. All right, passed. Sweet.
Cool.
All right, so now let's go back to this guy, right? Okay, so we have our input. We're gonna parse with our day14.parser, which is a text to a whole bunch of points. So day14.parser, let's get this in the right namespace too. Okay, this thing is going to take our input and then we're going to run that through our good buddy Phil. And then we have a set.fold across those, and each one of these things, what we're going to do, we're going to grid.insert. That sounds good. Let's write grid.insert. Day 14.grid.insert, which is going to take what? A point, a cell, grid sounds good. Let me see here. I have a point and a cell and a grid and a grid. I don't think we want to do it like that though. We have a point and a cell, and that we can do. That's better. So for this, we do grid.insert. Is that right? Set.fold grid.insert on. Okay, let's see if we can do. We're going to want to do from input. After we fix whatever's wrong on line 36. Phil. What's wrong with you, Phil? That takes a. Okay, day 14.fill. So right here. It takes a list of points. Parser input gives us a list of
Oh.
points.
Do we just need a map?
And that we're going to have to do. So that's a list.map. Yeah, wait a minute though. If we list.map, that gets us back a list of set of points. Yes, and then for each of that, we're going to do list.map across all those with this set.fold. That's going to give us back a grid. Oh, that's going to be a list of grids, isn't it?
Yeah.
We're gonna do it. Watch this. We're gonna do a. Well, what are we gonna do? How are we gonna do that?
I stuck my map in a
We're
store.
We're gonna do a fold in a fold. Hang on, I gotta think about this real quick. Okay, so stop. Okay, each time we get a list, what are we gonna do with it? We're gonna have a. We're gonna be getting. This is going to be a grid, and we're gonna get a cell. We're gonna get a what? We're getting a point, and then what we're gonna do is we're going to do grid dot insert a with P a sand. No, a what is it? A wall.
Mhm.
Yeah, we're doing that with each. No, okay, with each list though. Sorry. We're gonna get a grid and we're gonna get a list of P's. A set of P's. And that we're gonna do set.fold grid.insert P wall with the P we get and the grid we get. Shit. No, we already have the grid. Why is that? So this is just going to be a unit. We're going to ignore the left. How does set.fold work? View set.fold is accumulate. Is it? Do we have fold left and fold right? Yeah, we have fold left and fold right. So we're going to do a fold left and ignore the first one or something. No, we're going to do a fold. Sure. And I'm going to ignore this. Grid.insert P wall. And this fold left, we don't care what it folds over to start with because we're accumulating nothing. Shit, that's not right. How does that work? No, we can't do it that way. We need the grid. Grid is insert P wall grid. That starts on some grid for each PS. And this is grid.empty. Okay.
You might need to disambiguate one of your grids.
No, I don't have to, but all right, that seems to give me a big thing. I'm gonna wish we could print it. Should we try to print it?
Yeah.
How does
we
that
can
work?
use
Oh
the
shit. Yeah.
list on map or try and draw an actual screen.
Yeah. Okay. So we're gonna need like a min X and Y, right?
Yeah.
Like we need, or let's do a thing. We're gonna want something that's gonna be like a day 14 grid dot bounds that returns takes a grid and returns 2 points. That seems reasonable to me. And we're gonna do that. Day 14 dot. Let's see. What do you think? What do you got? I don't like it. Okay, we're gonna do. Okay, this is gonna be a map dot fold left with key, and that takes an ACC. Yeah, yeah. Yeah, what do you think? Wait, what does fold right with key look like? Actually, that might be more ergonomic. No, it's no better. Well, key A, B, B. Yeah, that's better. All right, so we're going to do fold right with key. Is that better? Yes. So then we get to go this, this. We get to cases. All right, so what does my accumulator look like? My accumulator looks like a min x, min y, max x, max y. No, we're going to do it like this. Point, min x, min y. Min x, min y. And a point. Max x, max y.
You want me to get rid of that comma in between max x?
Yes, thank you. Okay, that might be right. We're going to trust it for now. Um, 72. What did we do? Grid.empty. We didn't finish something up here. We didn't finish our fold right. All right. So that we are folding right on. Yeah, looks good. Min. Let's use nat min max. All right, what are we doing now? Mat p.x. You don't know what we're talking about. Yeah. This is min. Shoot, that's right. This is really I gotta destructure. All right. Is it really 0 to... Okay, so let's print one of these things. No, I want a grid to text. What am I talking about? Okay, yeah, all right. Let's destructure these. max X, max Y. All right, so what are we gonna do? We're gonna do, we're gonna need we have a grid dot insert. We're gonna want a day 14 dot, exactly. You know what I'm talking about. What is this really saying? Grid M, match grid point X with some, oh, interesting. Okay, that's good enough. And then let's make a cell to text.
Yeah.
Perfect. Not really. What are they using in their examples? It's using dots for empty and O's for sand. Oops. All right. And print. All right, grids, bounds, G. Yes, we're going to say, all right, what are we doing here? Are we doing an each? No. We
Yeah,
want,
we could do like
no,
an
we
each
want to,
yielding the coordinates.
hang on. I'm going to do, how about if we want a row of n? What does that look like? That is, yes, text. No, row, nat, text. I like it. It's not going to work, but hold on. What are we going to do? We're looking at all that. We're looking at this list from min to max. And then each one, we're going to go over it. We're going to say get grid deck, get point for that Y. We're going to cell.text and text.join. Yeah, that actually works.
Yeah, I think that's wow.
All right. Yeah, you got
Copilot.
yeah, look, okay. Perfect. Oops. Yeah, that looks sketchy to me. All right, let's see. Match this with some or none. Okay.
So we might need to print line it in order to make it actually.
Yep, that's what I'm gonna do.
better.
So let's do. Oh, it's too wide. Is it too wide? Is it really that wide? Do we really have something on 0? Is that the...
There is nothing at 0. I think what's happening is in the bounds checking, you're sending in 0, 0 as the minimum. And
You were
it's never getting beaten.
absolutely right. You're totally right. Thank you. Yeah. Totally right. You got it. Yeah, how do we really want to do that? We really want to be smarter about this.
If you want to be not smart, I suppose you could use natmax.
Yeah, good one.
Yeah.
I like it. Beautiful. Thank you.
Oh, it's lovely.
Teamwork makes the dream work. All right. All right. So in this, okay. So now what happens? What are we even doing? We're now like, they're coming in at a certain point, right? What's the point? They're coming in at 500, 0.
500, comma 0.
All right. And do we simulate that one piece of sand until it's all the way done and then we're done? Unless it falls off. And falling off the bottom means it goes lower than the max Y. All right. All right, so let's just like, so which, okay, no, we can leave that there. That's all good stuff. Let's say that we're going to print a grid. Well, we'll keep this. We're going to say something that prints a grid is going to no, we don't need that. We don't care about this. Okay. What are we doing? Day 14. We want something that's going to be like the next step, which is going to take like so each step we have a grid. What else do we have? We have a sand, which is at some position, right?
Right.
We have a goal row. And what is the thing we're trying to figure out? What's the answer we want? Is it just how many, okay. How many before, so we just need to know how many rounds before this happens. And so this is going to be, okay, day 14. At each step we have a goal. We have a piece of sand. We have a grid. And we're trying to do what with this? We are optional. We are trying to say what do we have to do? We have to return a grid. And what I'm going to say, let's be cheeky. We're going to be totally cheeky about this. We'll take the current round. And if we ever find the gold condition, we're going to just throw it down there. No. That's not good. What are we going to do? What are we really going to do? How does this
I
work?
like the idea of the step function.
We're just going to say whether or not... Right now I'm going to say I want to return a grid if there's more work to be done. Otherwise, we're going to say that our sand fell off. So none means our sand fell off. Let's write that down. Oh no, I just want to do... sand. Okay. How does this all work? Okay, we say, first of all, we're going to just say, if the sand, what is our goal? We would check the goal condition, basically. I'm going to match sand with point, don't care about the X, but the Y is if Y is less than or equal to goal, or greater than or equal to none. Oh, wait, yeah, else. We're going to eventually want this X. All right, so now what do we have to do? We have to look at the three. We want to match. Let's do grid.get. What are we getting? We're getting Yeah, point x decrement. No, we're gonna check. We first check xy. Then we check point. Which one? To the left or the right first? Left first. Point. Let's say we're really checking point with our next y. Else we really want y prime to be increment y because we want the row below. All right, so this is y prime decrement x and y prime, and then point increment x and y prime.
Should we do this in a helper function, or do you want to do it all?
Maybe. All right. So what are we doing with this though? Okay. Yeah. Sure. Let's fall down equals is going to be this thing. This is going to return an optional. What does this return? This returns an optional point, I think.
In what case would it be none?
When all 3 spots are filled.
Gotcha.
So we're gonna match. Okay, we're gonna do. This is actually grid.get. Sorry, this is gonna be a tuple of 3 things. Grid.get this on the grid. Grid.get this thing on the grid, and grid.get this thing on the grid. Someone's not in the right spot. Grid.get that on the grid. Yep. Sorry, this is all one big match. Those 3 things in a tuple. And so now, if we have anything with a sum. Oh, how does this work? Okay, if it's sum anything. If it's sum empty. Then we return. There's more work to be done in a grid, which is grid.insert at point xy sand in the grid. Wait, so I need to return an optional. I need the next point too. Right, okay, so I return the point where we're at. So this is x, y prime, and a grid with that new spot set to sand. No, that's not what we do, right?
Yeah, because it could keep
Yeah.
falling.
Yeah. So it keeps
we
falling.
Need like an until.
Yeah, how does that work? What do we really want to do? We really want to.
We want to call.
Recurse. We want to recurse at that point.
Yeah.
I think you want to fall again.
Yeah, that's going to be the recursion, I think. So we're going to do step with the same goal. Yep, that looks good. Okay. No? Okay. If there's nowhere for it to fall, then we... Wait, when do we return a sum? We return a sum. We have to check our goal condition, right? That we do that. Okay. Yes. Okay. That's the none. Okay, here we're going to return a sum with, this is going to be grid.insert at the sand can't fall, so we put that sand in the grid. Yep, that's it. All right, so that's one step.
I don't think that's going to type check because fall is optional point.
Let's see, hold on. This is saying probably exactly what you just said to me. Sorry, I'm probably being slow. This is fall returns, oh wait, so what is it saying? Fall equals, this whole match is saying it's a maybe, and it wants, what? What thing is returning a cell? Dave grid.get is returning a cell. Right, they always return, grid.get always returns a cell. Gotcha, right, because we can always get, yeah. I didn't hear who, I don't know who it was just talking, and if that's exactly what you're saying, thank you.
I think there's another one. Yeah, this is the one I was talking about.
Okay, and in this case, yeah, hold on, I don't see it. Which one were you talking about?
So on line 108, you've got fall optional point. On line 113, you're returning a grid.
Perfect, and that's not perfect, but you are. Thank you. All right, we don't have an X on line one. We should have an X, don't we? Fall equals match grid. Oh, we don't know what X is? We lost that somehow? Wait, no. Where did X even go? Where did it come from? That was down here.
Yeah, maybe the first line you could decompose sand.
No, I think this whole thing can just go inside the... and now we're calling fall. What does it take? Fall is just a thing. Yeah, we don't need a thing. This is just a thing. We don't need to call a fall. We just are a fall. This is all we do. Is that right? No, because we need a recursive. We know we need a recursive call, right?
Yeah, you've got the recursive.
I've got the
call
recursive
on
call. Yes.
112, 13, 14.
Yes. Thank you. It's not a call to fall. It's a call to. All right. So now, perhaps, are we getting close to like an actual solve? Look, it thinks we are. What is that going to do? That's going to take a text, and it's going to produce a NAT, hopefully. Let's call this part one, because we know what this is. Okay, what do? We have to parse our input first. Hey, look at this. No. It's increment max y is our goal. Okay, so our goal is that grid. All right, I think you lost the story after this. Okay, so we have an input, we have a grid, we have a goal. Now we're going to say, what are we going to say? We're going to say, let's make a little, the point is 500, 0, right?
Yep.
Huh. Okay. Increment is a nat. Where did I say int? Where did I let an int slip in? Let's see. Oh, it just doesn't know which one we're using. Okay. And then, yep, we gotta go 1. All right, and then let's try to solve on our test input. Fine, 0. I don't know if that's right. Is that, wait, what does that make sense?
Is that right?
It seems like it should be.
Did they give an example, like full example?
They did.
It was 24, right? Yeah. All right, we totally got it. Edit day 14 dot part 1. Wait, you weren't ready for me, were you? Oh, shoot. All right, what's actually, is this all the right thing? I'm going to add the stuff. Okay, and then edit day 14 dot part 1. Part 1 dot solve on day 14.
Oh, do we need to text the result?
No. Yes. Fine. Not dot to text after that thing. What do we think?
Well, I think
Oh, okay. Okay. Pardon me.
Everybody look away.
No, I have more than one screen. What do I do?
oh, you have to go to your browser tools and look in application.
Oh, you're right. That's what I need to do.
Yeah, and then you'll see a session cookie.
Fine, you get to look at a blank screen then. So I go to, where's my browser? I open up Inspect. I go to, oh, fine, where is it? Oh my gosh, I need a bigger window than I have over there. Where is this thing?
We can see your.
I know.
compare.
Yeah, you're totally going to be able to submit answers as me. Where do I find this thing, though?
Oh, yeah, I'm going to mess up your percentage.
Yeah. Seriously, I thought it was in here. I want to go to Inspect, right? Yeah.
It's not an application?
In Firefox, I believe it's under storage.
I'm used to seeing it down. Oh, perfect. Okay.
Is anyone else hearing Rebecca twice?
I'm
Yeah.
hearing me twice.
Oh, that's probably my fault.
The
Um,
universe can't contain this.
I don't know. Okay, so that's copied. Okay, you can go away. No, wrong one. All right, so now I need to go to share stew public advent to code, and we're gonna try again. Run day 14 part 1. That's not part 1. No,
Oh, did it not pick up your update?
it did not. You're right. I didn't because I restarted. Yay. All right.
Yeah, good job.
Thanks everybody. Thanks for your help. I didn't even catch who was it. Who's Mr. Know-It-All over there? Thank you very much for your help along the way.
You're very welcome.
All right, so if we refresh, we get more stuff now. Oh, I misread the scan. It isn't an endless void. There's a floor. 2 plus the highest y. Okay. Let's find somewhere safe to stand. Using your scan, seem like the falling sand until the source of the sand becomes blocked. Okay, so we have to keep on doing this until it's blocked. And then we got to find a place to sand. All right, so fun. Okay. All right, so we need to initialize our map with this additional floor first. Oh, that's infinite. It's infinite. It's infinite. All right, we're going to deal with that, I guess, in our... All right. So we won't necessarily initialize. We're not going to put that into our grid then, if it's infinite. Okay.
That would take a very long time.
It would. Thank you. Yes, we're not that lazy as we. All right, but we can work with this. All right. So for our, we're gonna, let's say we have a print step. This step is going to be different. It's going to be similar, but it's going to be different. Let's first let's move day 14 dot step move dot term day 14 dot step to day 14 dot part 1 dot step. And I'm just going to do that here real quick just to make it line up. All right, so day 14 dot part 2 dot step. What is that going to look like? I'm going to actually, I'm going to start with them being the same. Okay, but part 2, what we're going to do is we're going to return. What do we have to do, though? In part 2, we have to return when it's blocked. We have to say when there's no more, when we couldn't insert the point at all. Which means as long as we got past the first step, we keep going. Okay. All right, so in here, let's track an additional how many steps we've completed so far. So that's a nat for how many steps we've completed so far. And so every time we recurse, we're going to increment that. So where's our recursion steps? Are day 14 dot part 2 dot step, because these are part 1 dot step. So in these, we're going to do an increment steps. Is that right? Okay, instead of our goal, though, that's the thing. We don't want to know if we've reached our goal. We're going to use our goal is now going to be really the floor, right? That's going to be the floor. And if it's greater than if it's greater than or equal than the floor, then we've reached the bottom. And we're just going to return that point. I think this thing always returns a grid now. If we've hit the floor, then what do? Then we're going to return a grid dot insert point. Otherwise, we keep going and try to place it somewhere. And at the very end, we were returning, what is this? What is our, so we've matched all this. We didn't find a place to put it. If we didn't find a place to put it, yeah, then we return the grid with it inserted. No. We really want to return, in all these cases, I want to return how many steps we took as well.
Yeah.
So it's going to be a nat and how many steps before we got stuck.
I think the puzzle is asking for how many grains of sand can be placed.
No, this one is we got to find a safe spot. So we have to keep inserting them until the very initial one is stuck. And then we gonna have to scan across here and find like an empty row, I think, right? Isn't it? No. Oh, what was it? I didn't read the whole thing.
Empty row thing is like the story.
Oh, I don't have to care about that at all? Oh, I didn't read the whole thing. Shit, you're right. All right, so I just need to, I still am just looking for the N again? Okay. Oh, I screwed up the whole thing. Okay, so we have to keep going. All right. So instead of how many steps I can take, I can just also just return the last point returned. The last point that we inserted. That would work, right? I like that better.
For the step function and then delegate the counting to the other function, like before?
Well, I just need the stop condition is when I can't place when I can't put any more in. So that's going to be like when this is the initial, right?
That's the type signature for part 1.
Thank you. Dude. Man, okay. All right. So I don't really care how many steps I've taken. I do care about what? I'm going to say we're done. It's the same kind of thing. I can just say we're done. I could know when we're done. How could I know when we're done? I can know when we're done. All right, so we matched. We have a place to done. We had no place to stick it here. Okay, so now, what do I have to know? I have to know, basically, it's really if freaking y prime is, if it equals 0, then I'm going to return none. Right? Does that make sense? I didn't have a place to put it.
I don't think you even need the if, because how else could the sand be stuck?
Yeah.
Yeah.
Yeah, I think that makes sense. All right. Okay. The steps things goes away. That was a. Okay. Does it blend? $123 grid dot insert. I'm insert. How did I mess this up? So I'm inserting a point into a grid, and I need to tell it what to insert. If it's the floor, that I'm inserting a sand. $121. No, where is it saying? I have an if on one side's a okay. One side of my if is a sum, and one is not. So where's? Huh?
Does grid dot insert return an option?
No. It doesn't. This is a sum. Thank you. I don't really need this. 125. We don't have goal anymore. It's called floor. Okay. Part 2 dot solve. We think we're taking a text. We're gonna do until. Is it just the same?
Think so.
Except, wait, we need to set our floor. It's going to be double increment.
Oh, because it was +2.
Our floor, I think, is +2 from the bottom, yeah.
I think, yeah, okay.
Also, line 154, you're calling part 1.
Thank you.
Mr. Lifesaver again.
We need that namespace directive back in the files.
I know. What do you think?
Oh, bummer.
Bummer, we totally messed it up. All right. Let's see. Let's run it on our test input. On our test input. And let's just test equals do that into dot print into print line.
Solve returns a nat. Not a grid.
Yes. Yeah, I did that part already. Wait, what? Hold on. That's on line. What? Line 7. Yeah. Now I'm on 164. Okay, test input. Oh, wait, solve. Oh, now I understand what you're trying to say. Thank you. I don't really want to solve it. I want to print the grid after we're done. Is that what I want to do?
Yeah, you need to go like before,
Step.
after you've gotten rid of
Yeah.
the none case.
Okay, what do I want to do? I want to like kind of do this.
In these situations, what I sometimes do is I take the thing I want to be printed and then spit it on a new line and just debug trace it, and I usually get a good enough view of it in the console.
Yeah, but it doesn't. Oh, yeah, I really want this. Wait. No, I'm just gonna do it. I'm gonna.
You could emit it and then
I like it.
capture it. Sometimes I'll do that. It's like I just want the text or the thing, so I'll emit it, and then later I'll grab it.
Oh, I'm just doing the thing. Okay, if I get a grid, some grid, and then go this grid. No, if it's none, I'm returning the
I think
grid.
just return the grid.
Yeah. Into
Print grid there.
There's no sand in there. Why is there no sand in there? I never inserted sand. Wait, so part 2 dot step. I should insert sand when we hit the floor. That's my sum. I return the sum. And that down here, when I get the sum, I increment the count and I do it back again with the grid. Go count grid point. Part 2.
You're changing part 1's solve.
Thank you. Why am I doing that again? Thank you. All right, so, and so I'm not, and yeah, I'm never inserting sand in this one, am I?
Oh, isn't it when it can't move, you should be inserting sand?
Wait, where? Step. I am inserting sand, right?
Yeah, well, I went on line 132 when
Yeah.
there's no empty space for it to move. It should stop. Like on line 122.
Right. But wait, when do I return the none? I return the none when this, okay. So this is the case. I do need to sometimes return none and sometimes return some here. When do I do that? I do that when the y is still, when y prime, I couldn't match it if y equals 0. Then none.
Yeah,
Else, otherwise we're doing some with that. There's sand in there now.
Do we?
That's not
need
the right.
if Y
I see for
is-
sure that's the
Are we
wrong
off
point.
by 1?
Yeah, we are. We're off by 1 again. I didn't update. Wait, why didn't that? I'm a little bit confused. Why didn't that work? Wait, what's going on? Wait.
The increment thing, or is it in your?
I incremented.
design doing
Yeah, I duplicated code.
Oh, okay.
Oops. That looks better. All right, let's get rid of test. I didn't actually check my answer with the first one. See if we got it right for the first one, but
I sort of followed the same general pattern, and it took about a minute.
Ah.
oh, I'm gonna wish I could. I should totally have. Well, that's all right. I was gonna say we could print out what our result looked like.
Yeah, I ended up putting if count mod 100 is 0, then print count, just to sort of keep track of it going, because it took so long.
We're watching the sand drop in real time.
There's a certain irony to the sort of falling sand like a sand. tunnel.
Exactly. Yeah. Yeah. Totally. Yeah, I think we've recently identified that maybe our maps are on the slow side.
I naively tried to use a NAT map for the X coordinates and NAT sets for the Y.
NAT maps are known to be slow right now. That's something we're actively looking into. We know that there's a performance issue with NAT maps that we're actively trying to track down. They are slower than maps of NATs, which should not be the case, obviously.
I see some people doing advent of code in like C++ or Rust, and they're like, "Oh, it took 0.3 seconds." Yeah. Didn't pick this language for the speed game.
Yeah, well, we do think that once we move to our new runtime, when we move to the scheme-based runtime, things should get a lot faster.
I was at the ICFP conference in Berlin.
Oh, yeah?
And the Racket guys gave their talk about changing backends. It was pretty good.
Cool.
Awesome.
Boy, I did some things where I was like totally not being as efficient as I could have, because I was like, how slow can this be? But perhaps it can be kind of slow, huh? Oh, I should check my... No, we're not. You're using tons of memory or anything. We're good on memory. Yeah. Come on. Is it really this slow?
Yeah, it really is. I think the answers are in the tens of thousands.
Oh, okay. So it's a big thing. Okay.
Yeah, at one point my simulation was taking a while, so I just took one of my like counts of how many times it's sort of gone through so far.
Yeah.
I submitted it and it said, "Your answer is too low."
Now I want to put something in there, but I don't want to stop it if it's about to be done. Well, that was pretty fun. That wasn't as bad as I thought it was going to be when we first started going. Bummer, I got the wrong answer. Shit. Oh, no.
I bet it's like off by 1.
I do think it is off by 1.
We should use the tiny input and then see what they gave us for the count.
Yeah, I bet you I'm under by 1. I will say almost definitely I'm under by 1. Okay, so what do I want to do?
And the best bit is you don't have the answer you had, so you can't just add 1 to it.
No, exactly. Oh, I have to run it again, you mean?
Oh, wait, no, you do. Because, oh no,
No.
you have to remember to add the last run.
I have test input.
Oh, no, you can,
Yeah, it's off by 1. I knew it's 1 under. I'm totally gonna...
do add.run in the UCM.
Yeah, but that's just gonna... I mean, that only saves the thing that it, like... That would...
Did you not
It doesn't...
return
I
the
didn't
number?
return the answer. No. No, I don't. It's because I ran the submission thing.
Right.
I'm gonna... Okay. Oh wait, before we okay, let's put some kind of a counter, or what should we leak out there? Um, we're going to
We need a spinner ability.
yeah,
Ooh,
that would be
project.
great.
Yeah, or like a progress bar as well.
Yeah, that would be fun.
That'd be cool.
So
I think
what do
we
I
can do
want
that
for
with
each?
this ASCII library because you can do the clear command thing.
Yep. Okay, here I'm just gonna say, what am I gonna do? How am I gonna know? Oh, this nat is what? That's the goal. That doesn't tell me anything. I really want.
I think you want to put it in your go function.
On this is my
Like on
count.
line 158.
Yeah, yeah. Well, we can just say. Something like that. If that, then I want to. How about that? Yep, IO. You're allowed to do IO. That's fine. You can't do IO, but everyone else can. Uh-huh. Run day 14, part 2. I think I can. I think I can.
Would it be any faster if we rewrote the map implementation as like an ability-based key value store thing, or I guess it'd probably be
No,
backed
it's
by
yeah, it's I don't know. I wonder if we can I wonder if we have I don't know. I think we could make a built-in ability that's a map that's based on more like a hash map that uses the built-in hash or something. I wonder if we could do something like that. I don't know.
Yeah, have it exposed by base.
Yeah, I mean I don't know. I mean, because right now it's a binary tree, and which is log n input inserts, and I wonder if we could do better with a hash map based tree since we do have hashes for everything, because then it could be linear time inserts. I don't know. I just run the servers. I leave those kind of things up to people like Runar, Paul.
Yeah, it seems like a Dan.
So
question.
yeah.
While this is running, I have a question.
Yeah. Please shoot.
In a lot of places, you do cases with like a single arm instead of what you do in other places where you do like the deconstruction on line 152. Is that just a personal preference?
Yeah, it's yeah, I think I tend to really lean on our cases syntax when I can like destructure the. I think I tend to do that when I'm destructuring the last input of a function. There's no, it's absolutely all the same thing. Like underneath, it all turns into the same code. I believe there's no way to prefer one over the other than stylistically, at all, as far as I know. For that, yeah. I'm probably not always making the most handsome choices, but no, to answer,
Okay. I suppose then I have sort of an ergonomics question thing. I think it was back on day 2 or day 3. It was rock paper scissors,
Yep.
and I implemented like a move, and I implemented my own equals operator on the moves. So like in my advent of code namespace for day 2, there's like this move dot double equals.
Right.
And I find like when I'm writing a lot of code, like if something else is not type checking for some reason, because it's in my code base and not in lib, like it gets priority, and I tend to get like a lot of errors, like you've passed a nat to move not double equals.
Yes. Okay. So let me just try to restate what you're saying, just so I make sure and let me know
Sure,
if I'm. So let's say you have. Well, we could do it with one of our types that we implemented up here. We can make a point that equals. So we're talking about a day 14 dot point dot equals equals that whatever
Exactly.
does this, right? And so now what you're saying is that all these other places where you were using double equals, all of a sudden it's finding this one instead of like the nat double equals. Is that?
Yeah.
Yep.
But I was sort of thinking the name resolution was a bit more type directed.
Yes. It is, and I don't know. I'm not the. Hey, Chris, is Chris still around? Would you know
No.
better? Yeah. Who do we have that might know better? No one. It's no one. We do have type directed name resolution, and I would not be surprised to learn that it gets messed up when. Okay. Well, sorry. Let me slow down. Yes, we absolutely do deprioritize stuff that's in your lib directory. I know that for a fact, and I would guess that that is what's messing it up. Is specifically we will always promote something outside of lib before something inside the lib, and I'm guessing that that will trump the type directed name resolution, and that is a bug. And I'm not surprised it's happened. But hold on. Let's talk about that. Let's
Also,
not.
you got the right answer.
Oh, sweet.
Was it finished?
Oh, wait, did it run? I wasn't even paying attention. Did I submit? Yes, I did. Great, thank you.
Yay, good job.
But let's. I'm going to. Exactly what you're just talking about. I'm going to bring it up in our Slack and see if that's something. See what people have to say about it. But sorry, what is your name, if you don't mind me asking?
It's Joe.
Hey, Joe.
I'm like halfway up the screen now.
Oh, Joe Harrison. Okay, fantastic. Great. Thank you so much. But let's talk about it. Can you and I start a conversation after this in here, and let's see if we should get a.
Yeah, I'm happy to do this later.
Yeah. I just mean like let's not. I don't want to watch me type to you. But let's start a conversation in the Slack and see if we should be getting a bug filed about it, and see, because then we can get other people who actually work on the TNDR in there commenting to see whether or not what I guess is going on is what's going on.
Okay, thank you.
All right. Anything else we want to talk about? It's like a good time for me to wrap this all up. Any other questions from anyone? If not,
I have a question. If you're the infra guy, then
I am the infra guy. Yes, please. I am one of two.
Is that also backed by the SQL database?
It is. It's a bit. It is. It's not. Well, no. It's better than that. Right now, unfortunately, the implementation, which is not our ideal implementation, but it was one that we could kind of move quickly on, was that right now each individual user has their own SQLite database on the server, which is a huge. It's not the ideal way of doing things for many, many reasons. But like I said, it was the one that we could get up and running fastest. Our goal is to move all that stuff into Postgres. It's just not at the top of it's not the most broken thing right now. It's obviously terrible for me for scaling wise, because I can't scale horizontally as easily until we do some like user sharding or something like that. So like essentially right now, share is one big instance that has one big disk that's got lots of SQLite databases on it. And so that's, and that like, because of that is why you'll find like we have some things that are kind of obviously missing, like cross user search. Like you can't search for a term and hope to find it in many different users' repos. You kind of have to get into a user repo and then search there. And that kind of is because of the way that things are going now. Does that kind of answer your question?
It does, thank you.
Yeah. So like I said, the goal was to get that all moved into Postgres, and then we kind of have one big Postgres database that backs all of Share. But it's just one of those. Yeah, it just hasn't. It's kind of a big rewrite because it's unfortunately SQL stands for structured query language, not standard query language. Essentially, that's the big problem. But it'll at some point pretty soonish. I'm hoping it's going to become enough of a scaling problem that we're going to get motivated to move all that stuff, and then we'll get some better features on Share as a result. But good question. Thanks for the question, and thanks so much for joining us today. You were super helpful, and it's been great seeing your solutions coming up in the chat as well.
No worries.
Anything else from Joe or otherwise?
That was great, Stu.
Okay. Thanks.
Ship it.
Cool. Ship it. Yeah. If not, then until next time, I'm waving, even though no one could see me because I don't have my camera on. But thanks everyone who joined, quiet or otherwise.
Thanks, Stu.
Yep.
Thanks, Stu.
Thanks, Rebecca.
Bye.